What specific problem does the NeedleBench and ATC methods aim to solve in the context of evaluating long-context LLMs?
The NeedleBench and Ancestral Trace Challenge (ATC) methods aim to address the limitations of existing evaluation approaches for long-context LLMs, particularly in their ability to extract and analyze information from lengthy texts. NeedleBench provides a customizable framework that includes tasks for single and multi-retrieval, as well as multi-reasoning, allowing for a comprehensive assessment of models' capabilities across various text lengths and depths. The ATC specifically simulates complex real-world scenarios by testing LLMs on multi-step logical reasoning tasks, requiring them to integrate and understand multiple pieces of information to answer questions accurately. Both methods emphasize the need for models to not only retrieve information, but also demonstrate strong reasoning capabilities, which are critical for practical applications like legal analysis and business intelligence. Ultimately, these methods reveal that current LLMs struggle with the complexity of real-world long-context tasks, highlighting significant areas for improvement.
How does the proposed NeedleBench framework work? Illustrate the methodology step by step, including the roles of SRT, MRT, and MRS in the evaluation.
The NeedleBench framework is designed to evaluate the long-context information extraction and reasoning capabilities of LLMs through a structured methodology. It consists of three main subtasks: the single retrieval task (SRT), multi-retrieval task (MRT), and multi-reasoning task (MRS). 1. SRT focuses on testing the model's ability to recall a single piece of key information inserted at various depths within a long text, assessing precision in navigating extensive documents. 2. MRT evaluates the model's capability to retrieve multiple related pieces of information scattered throughout a lengthy text, simulating complex real-world queries that require extracting several data points. 3. MRS challenges the model to perform complex reasoning by extracting multiple pieces of information and logically answering questions that necessitate an integrated understanding of various text segments. Together, these tasks provide a comprehensive assessment of LLM's retrieval and reasoning abilities in handling long-context scenarios, ensuring a rigorous evaluation of their performance across different lengths and complexities of text.
What theoretical or practical benefits does NeedleBench offer over existing methods for evaluating LLMs in long-context tasks?
NeedleBench offers several theoretical and practical benefits over existing methods for evaluating LLMs in long-context tasks. Firstly, it provides a customizable dataset framework that includes tasks across multiple length intervals, 4K to over 1M tokens, and various text depth ranges, allowing for a more rigorous assessment of both retrieval and reasoning capabilities. Secondly, NeedleBench introduces three distinct subtasks: single retrieval task (SRT), multi-retrieval task (MRT), and multi-reasoning task (MRS), which simulate real-world scenarios requiring complex information extraction and logical reasoning, thus aligning evaluation more closely with practical applications. Additionally, the Ancestral Trace Challenge (ATC) test is designed to stress-test multi-step logical reasoning, revealing the limitations of current LLMs in handling complex logical relationships. Overall, NeedleBench addresses the misalignment of existing evaluation methods with real-world tasks, providing a comprehensive and targeted assessment of LLM's long-context capabilities.
Can you explain the experimental design used to validate the effectiveness of the NeedleBench and ATC tests, including details on the datasets, metrics, and benchmarks employed?
The experimental design to validate the effectiveness of the NeedleBench and Ancestral Trace Challenge (ATC) tests involved a comprehensive framework that included various subtasks and metrics. NeedleBench was structured into three main subtasks: single retrieval task (SRT), multi-retrieval task (MRT), and multi-reasoning task (MRS), each designed to evaluate the model's capabilities in retrieving and reasoning over long texts. The datasets utilized included the Paul Graham essays for English and the Chinese domain modeling eval for Chinese, ensuring diversity and quality in the text sources. Performance metrics were based on recall accuracy of the needles, key information, placed at different positions, with the Levenshtein distance used to assess the similarity between model predictions and reference answers. Additionally, the ATC test employed multi-step logical reasoning problems, with scores averaged across multiple iterations to ensure stability and reliability in the results, highlighting the model's reasoning capabilities under varying complexities.
What specific results were achieved with the NeedleBench and ATC tests, and how do they highlight the performance or limitations of the evaluated LLMs?
The NeedleBench and ATC tests revealed significant insights into the performance and limitations of various evaluated LLMs. For instance, the intern LM2-7B200K model achieved perfect scores in the single retrieval task, indicating strong capabilities in accurately retrieving single information points. However, it experienced a notable decline in performance during multi-retrieval tasks, suggesting overfitting to single tasks and highlighting the need for improved instruction-following capabilities. The ATC tests demonstrated that models struggled with multi-step reasoning, as accuracy dropped below 10% for most open-source LLMs when the number of reasoning steps reached around 16, indicating their difficulty in handling complex logical relationships in long texts. Additionally, the results showed that models with larger parameter counts, such as Qwen 1.5-72B VLLM, performed better in multi-reasoning tasks, emphasizing the correlation between model size and reasoning capabilities. Overall, these tests underscored the necessity for further enhancements in LLM's long context processing and reasoning abilities to meet real-world application demands.
What are the main limitations or drawbacks of the NeedleBench and ATC methods as discussed in the paper, and how might these impact future evaluations?
The main limitations of the NeedleBench and Ancestral Trace Challenge (ATC) methods as discussed in the paper include the struggle of current LLMs to handle complex logical relationships and multi-step reasoning tasks, even with shorter texts. The ATC tests reveal that models often fail to maintain accuracy as the number of reasoning steps increases, with many open-source LLMs dropping below 10% accuracy when faced with 16 or more reasoning steps. Additionally, the performance of models like intern LM2-7B200K indicates overfitting to specific tasks, such as single retrieval, which can hinder their ability to generalize across different retrieval scenarios. These limitations suggest that while NeedleBench and ATC provide valuable insights into LLM capabilities, they may not fully capture the model's performance in real-world applications, necessitating further refinement and development of evaluation methods that better align with complex practical tasks. Consequently, future evaluations may need to incorporate more diverse and challenging scenarios to accurately assess LLM's reasoning and retrieval capabilities.